Hello, everyone, and welcome today to the Oregon Housing and Community Services Multifamily Energy Program, training on Energy Auditing 101. Thank you for joining us today. This is Steph Berkland speaking now, and I have Sebastian Kahn with me from the Association for Energy Affordability, our training partner on the program. Just a few housekeeping items for you today. We are using the GoToWebinar platform, and this platform, the way that it works is if you'd like to join the conversation or ask any questions, there is a questions box within the GoToWebinar panel, and just feel free to type in your question and we'll answer those in the order that they come in. Alternatively, at the end, if you'd like to raise your hand, we can unmute you and you can join the conversation via audio. So whatever your preference is, we're happy to accommodate that. So with that, I'm going to jump into the presentation for today, and we'll go to the next slide. So just a high-level overview of what we're going to be covering today is we're going to be looking at what is the purpose of energy audits and how they relate to the Multifamily Energy Program, also known as ORMEP. We're going to go into the different types of audits that are required for the program, and also, what to expect, how do you prepare for an audit, and then also look at the different types of systems that you can encounter in multifamily properties. So what is an energy audit? In the simplest terms, it's really a survey of the existing building conditions as they relate to energy use. So what we're doing when we go in for an energy audit is we're looking to determine what are the current energy uses, where are the energy saving opportunities. Additionally, we're also looking at how can we identify and improve safety and comfort for the residents. This is probably one of the big key ones for the program and also the low-income population. So there's a variety of different types of energy audits, ranging from whole building to system specific. So we'll get into those in just a little bit to talk about what are the different levels. So for the Multifamily Energy Program, there are different participation pathways. So there's a menu pathway, a bundled pathway, and a whole building pathway. So each of these vary in level of on-site work needed. The menu and bundled pathways require an energy consultant or the property owner to submit photo documentation of existing conditions of the measures that are being replaced. So if you're doing a lighting upgrade or an HVAC upgrade, we do ask that you submit photographs of existing conditions, but a full comprehensive audit is not necessary. Under Pathway 3, which is the whole building, all buildings on the property will need to be audited, and that is best to really understand the existing conditions of the property, and also part of that component and pathway is that an energy model is required for the program. So that existing conditions assessment, the information that's collected on site, will go into the energy model, which will help to calculate the savings for the program. So with that, I'm going to turn it over to my partner here, Sebastian, to talk a little bit more about the different types of audits. And Sebastian, thanks for joining us today.
Thanks. Thank you, Steph. And thank you all for making it to this meeting or this training. So for the audits, I want to start out by breaking them down into different types. ASHRAE, which is the association, the Society for Heating, Refrigeration, and Air Conditioning Engineers, they break down energy audits into 3 levels, which go into various depths of the audit. So at level 1, you're just looking at how to make the systems you have more efficient in a pretty simple manner. In level 2, we start looking at replacing systems and getting a little more in depth with analyzing the building's energy use. And then level 3 is the full package, looking at comprehensive recommendations, changing system types, doing a financial analysis of how much it costs to do the energy upgrades versus how much will be saved. And it can even get into monitoring with and collecting data on how the systems are currently used. So if you look at this chart, those three levels basically cover the vertical orientation of this chart, the depth of the audit. You can also look at the breadth of the audit, like Steph was mentioning. You can do an audit for just a single system over here on the left-hand side, or you can go through and advance to the entire building and look at all the systems in the building and how they interact with each other. So there's a whole range of different types of audits that can be done. Before we start the audit, there's preparation that has to be done. We collect data on the property, which can go towards the energy model, and generally that's just publicly available data. And most importantly, we have a conversation with the owner and or the manager of the property, where we can find out what systems are having issues, what the owner wants to get done, so what we're sort of looking to try and make work for that owner, and what they've done recently. So if we know that, say, the water heaters have been replaced recently, then that's less crucial for us to look at upgrading, perhaps. And then finally, we make the site visit plan. So we determine how many units we need to enter, because we'll need to go into a selection of the units, which I'll get into in the next couple slides. And then what equipment we'll need to bring. CAS, that's combustion appliance safety, that gets into if there are combustion appliances at the property. And then will we need extra equipment? If we'll be doing more intensive site visit, then we may be doing duct blaster testing, where we're testing whether the ducts have leaks, or blower door testing, things like that. So at the site inspection, we'll start out by discussing the site-specific conditions. So we'll talk to the manager of the property and the maintenance staff and the tenants, if that's possible. And they oftentimes have a better sense of, or not better, but just different sense of what's going on. They may be able to tell us that there's condensation on the windows, or systems are running more frequently than they should, things that give us a hint as to possible energy issues that we could address. Then we'll look into the common spaces, we'll look at the lighting, we'll look at mechanical systems, we'll get into any attics or crawl spaces to see what sort of insulation is in place. And finally, we'll go into units, and we'll go into a selection of units and look at the appliances, what types of HVAC systems they have. If there's combustion safety, we may do a combustion safety testing. Throughout this entire process, we'll want to be taking photos of everything, documenting everything we can, writing down things that can't be photographed, so that when we finish up the inspection, we'll be able to put out an entire report of what's in place and also what recommendations we have to make these systems as good as possible. For the audit itself, there's a lot of protocols that we follow. For sampling the units, I mentioned we'll go into a selection of units. We're using the ResNet protocol to determine how many units we'll have to go into. And they have a whole bunch of scenarios and specifications for every scenario. And those can be seen at that website that I have on this slide. But the very, very basic system of the protocol is that you take the units, and for every unit type, so based on number of bedrooms and wall area, that sort of thing, we have to go into one of each of those units. If there are a lot of units of one type, then we can group them into groups of 7 or fewer, and then we have to go into one of each of those groups. So generally we go into approximately more or less 1/7 of the units. Other protocols are the BPI standards, the Building Performance Institute. They put out standards for a lot of different protocols for testing HVAC systems and water heaters and combustion safety. Combustion appliances are less common, so combustion safety is often not necessary. For this program, it's not required, but it is strongly recommended if there are combustion appliances. And these protocols will look into checking whether there's gas leaks and high carbon monoxide, and whether the appliances are venting properly, that type of thing. once we are at the property and doing the site visit, I'm going to go through right now a whole bunch of slides of typical systems that we'll see. And so I'm not going to go into detail on every single system, but these will be good reference for anyone listening in right now to be able to sort of have an idea of what types of things are currently present and what we recommend, what are common recommendations to update them. So within the lighting realm, the sort of older, less efficient lighting are typically these ones over here on the right-hand side. So these are your incandescent lights, which are the sort of stereotypical filament light bulb, and HID lights, which are more of the lights that you'll see in floodlights and those types of fixtures. For the last couple decades, the sort of standard efficient lighting option for those would have been fluorescent lights. And so you'll see a lot of those, compact fluorescence or linear fluorescence. But now we have LEDs, which have gotten to a point where they are just as stable as any other light source. And they tend to last longer, and they're about 30 to 40% more efficient than fluorescence, and 10 to 20, they use about 10 to 20% of the energy of incandescence. So they're much more efficient than those. They come in all sorts of different bulb types or hardwired fixtures, although for this program, just keep a note that only the hardwired fixtures version is incentivized, but they're a great option for any light fixture. So for the lighting also, we take note of what types of controls it has. In units, generally it's just a manual control, but in the exterior and common areas, for exterior lighting, they'll typically be on time clocks or photo sensors, and if they aren't, we would definitely recommend that they be put onto those types of sensors. And in a lot of sort of common areas, such as laundry rooms or perhaps hallways, things like that, they may be motion activated. LEDs also have the option for some of the fixtures for bi-level fixtures, which basically are another type of motion activated system, where when there is no motion, they're at a very low energy point. So they're about 20%, say, of the energy use, and they're a bit dimmer. And then when they sense motion, then they become brighter, and so they save energy while never letting the space go completely dark, which is good for hallways and garages, those types of places. A huge energy user in most buildings is the domestic hot water. In areas where you have a more mild climate, that can use up to about 50% even of the building's energy use. It becomes less as the climate becomes more extreme, and the HVAC becomes the larger source of the building's energy. But within domestic hot water, there are several different types of systems. Central systems are less common here in Oregon, but they are out there. They'll still typically be gas-fired systems. And you can have a boiler like you see in these pictures here, where the tank is separate from the water heater, or you can have a tank type where the tank and the water heater are one system. For natural gas systems, generally we recommend to move to a condensing system. So over here on the right-hand side, that's a condensing boiler, and it uses the hot water, or the hot, moist air in the flue, and it reuses the moisture by condensing the water out to bring it from about an 80% efficient system up to, say, 95% or more. For in-unit water heaters, a lot of the time you'll be running into electric resistance water heaters, and those we will recommend that you move to heat pump systems, which are somewhere in the realm of 3 times or more as efficient for the heat pumps that you can just buy off the shelf than a standard electric resistance heater. So it's a much more efficient system, and the only thing that you have to be aware of is it's a little bit larger than the electric resistance system, and it does use air. It takes the heat out of the air and applies it to the water, so it needs to either be ducted or be in a space that has a lot of airflow. So you just sort of have to be aware of that when you're looking to install these systems or recommend them. In terms of the actual energy use, the draw on the building, it's about on par with the electric resistance system, though. The other option are tankless water heaters, and exist for both electric and natural gas water heaters, and they use much less energy because they only run when there's draw on the water heater. And for in-unit systems, there isn't draw that often, and so that means they don't need to run very often. However, they tend to have much higher required loads, and so you need to have a building that will be able to fit that. So either on the panel for electric tankless water heaters, or the gas line needs to be large enough to handle that for natural gas water heaters. Other water heater savings can be brought about by having low flow fixtures. So if you use less water, then you will need less water heating. But you have to sort of keep in mind that if you go too low, that will be unpleasant for the tenants. So, for a kitchen aerator, you don't want to go to a 0.5 gallon per minute aerator, but 1.5 is probably okay. Also, recirculation pumps. These are pretty much exclusively for central water heaters, but they run constantly usually, and so you can do anything from a variable speed pump, which is over here on the left, to a more simple aquastat over here on the right, which controls how often the pump runs by using the temperature of the incoming water. The system in the middle here is a demand control system, which does the temperature controls, but it also senses how frequently the water heater is, or the water is being drawn by the tenants, and then turns the pump on and off accordingly. One thing to keep in mind for central systems is turning the water heater off can cause some crossover issues, which is where the variable speed pump is more useful because it keeps a constant pressure in the system to avoid crossover. Just so you know what you're looking at when I refer to central water heaters and recirculation pumps, this is that type of system. You've got the water heater in the background here. The recirculation pump is this one here. It's an older, just standard single speed pump. And then you've got an aquastat attached to the incoming water line right here. Next, I'm going to talk about building envelope and insulation. So the envelope, just the entire exterior of the building where you're keeping the air out of the building from. And insulation is a huge benefit for energy savings. It prevents the HVAC system from having to be used as frequently. So different types of insulation you may run into are BAT, which is the standard fiberglass sheets, such as this picture here. Loose fill, which is this picture here, although it's a little hard to see, which can be fiberglass or cellulose, or rigid, which tend to be foam sheets. Another thing that you have to keep in mind with insulation is when it's being installed, that's a really great opportunity to look into airflow through the building and air leakage. So while you're in the attic or wherever you're adding the insulation, they can go and seal up the cracks between boards and the gaps in penetrations, and that will prevent unconditioned air from coming into or leaving the building when you don't want it to, or from having air that is from an unsafe, non-quality controlled air source coming into the building. One way that you can check if there is big air leakage issues is if there's existing insulation, this blackened edge on the insulation you see in these photos shows that there's airflow moving through those spaces. So I sort of mentioned this already, but insulation can be added to pretty much any of the exterior edges of the building. So the walls, the attic or the roof, the crawl space. In the attic, generally we're talking bats or loose insulation. In the roof, you may be looking at rigid insulation. The crawl space will be bats or rigid, and the walls, there's a few different options. If you're opening up the wall cavities, you can put in bats. Otherwise, you can do drill and fill, it's called, where you drill holes between each set of studs and push in loose fill insulation. Or I have EIFS there, which is an external insulation finish system, which is more of rigid insulation being put on the exterior. I mentioned air sealing, and then windows finally, if the building has single pane or older dual pane windows, moving to new dual pane windows are a great option. They're very energy efficient. They also provide much better air sealing than the older windows do. They won't provide as much insulation as actual wall insulation, but it's a much, much better system than the old windows that you'll run into. So for HVAC, there are a lot of different options, and I'm not going to go through all of these different types of systems that you'll run into. I'm going to focus on the electric ones, but I want you to have this so that you can look at it later and look at all the different types of systems that might come up. Within the electric resistance systems, there's three basic types for heating. There's baseboard heating, which looks pretty much the same as this hydronic baseboard. You'll have a baseboard with a bunch of fins on the inside that get heated and pushed, and the air goes through by a natural convection. Or you can have an electric resistance wall heater. A lot of times these are called cadet heaters. It's the brand, but sort of the Kleenex of wall heaters. And so that has an actual fan inside blowing the air out, but there's no ductwork. Or you can have a forced air system, which will have a ducted system and a big fan inside that blows the air through the building. And that will look a lot like the furnace here. This is a natural gas furnace, but it's the same type of unit a lot of the time. And that may be connected with an exterior air conditioning compressor, which will also provide air conditioning. Another option for air conditioning is PTACs, which is package terminal air conditioners. And they're less efficient typically than the full-size outdoor compressor, but they are an option for buildings that don't have ductwork. They just go through the wall. If you're for upgrading the heating and air conditioning, for electric systems, you're pretty much just looking at heat pumps. It's not really worth it to look at elsewhere. Heat pumps will provide both heating and cooling. And at this point, it's worth it to note that the Oregon program doesn't incentivize fuel switching. So if you do have natural gas heating, then you'll want to look into more efficient natural gas options. But for any electric buildings, heat pumps are the way to go. So they provide heating and cooling. They're very efficient, just like with the water heaters. The heating is multiple times as efficient as the non-heat pump option, and the cooling tends to be a little bit more efficient also. The heat pumps can come in sort of several flavors. Package terminal heat pump is the same form factor as the package terminal air conditioner. A split system heat pump is the same thing also, where the heat pump will just be that outdoor unit, just like this air conditioning compressor. And then it just goes into a fan unit on the inside. And then a mini split heat pump also has an outdoor compressor, but on the interior of the building, it just has these head units. You can have multiple head units connected to each compressor, but they'll have a fan inside, and they'll be able to, each one will blow heated or cooled air from that head unit. So there's no ductwork, just those head units. So I've been talking about the heating and the air conditioning, the H and the AC of HVAC. For the ventilation, you'll see sort of a variety of things. A lot of units will have some form of ventilation fans, bathroom or kitchen fans. Not all of them necessarily, though. But the bathroom fans in particular can be upgraded, and it is incentivized to a fan that has a sensor in it, either based on a humidistat or a motion sensor, or both. And kitchen fans, sometimes you'll run into fans that are hooked into the stove, where they only turn on when the stove is on, or they automatically, but that's less common. Another thing for ventilation is when you turn on ventilation fans pushing air out of the building, it depressurizes the building and pulls air in. So if you want a more healthy building, you can control the air that's coming in by having a supply fan. But that is balanced on an energy aspect by the fact that you are pulling in unconditioned air and adding an extra fan. So it's a bit of an energy penalty there, but you do get a healthier building. A way to sort of mitigate that energy penalty is by looking into ERVs, energy recovery ventilation, or HRVs, which is heat recovery ventilation. And those will run the two streams of air, the air coming into the building and the air going out of the building past each other, and they transfer heat between each other, so you have partially conditioned air, so that you don't have to condition the air that's coming in quite as much. Also, once you're in the unit, inside of the units, the person doing the energy audit will be looking at appliances. And so the big thing to look for, or for appliances, is just always make sure that we get this this model number for appliances. They typically won't have any information about whether the appliance is energy efficient or how much energy it uses on the appliance itself, so you need to make sure to get a picture of the model information. But for refrigerators and dishwashers, we're talking about moving towards Energy Star appliances, which is pretty straightforward. Washing machines also have an Energy Star rating. There's also the CEE makes ratings. They do tier 1, 2, and 3, with 3 being the most efficient. And front-loading washing machines are the most efficient option. They're typically about 20 to 30% more efficient in terms of water use and energy. Dryers have fewer options, but they are starting to come out with heat pump dryers, but they are less common, but something to keep an eye on. For stoves, we would recommend moving towards induction stoves. There's still an electric stove, but all of the energy that they use goes straight into the pan, so that makes it so that there's no energy wasted out into the general area, but also it makes them a little bit more safe because there isn't a hot surface. The surface is only heated as much as the pan gets hot. So you are less likely to start a fire or burn yourself, things like that. Finally, the last thing I'm going to talk about that the energy auditor will be looking at is the electrical system. So we want to look at the main circuit breaker and circuit breaker panels in the units that we go into to make sure that the system, the units can be able to handle whatever recommendations we come up with. And different circuit breaker panels may have room for additional breakers, or we may want to upgrade them depending on the situation. So it's good to know what is going on there. You can see over on the left of this picture, the main circuit breaker. This one is only a 50 amp breaker, which may not be sufficient. So we just want to keep an eye on that. We also want to take note of any PV system that's in place and old wiring. I have this note on here. It's good to take a look for it. In, say, the attic space, you may see knob and tube wiring, which is probably not active, but sometimes it's still hooked into the electrical system, and so it needs to be removed before any insulation goes into place. So at the site, I wanted to really emphasize that we need to document everything, and the energy auditor that comes will be doing this. Pictures of everything they see, taking pictures of model numbers, nameplates, conditions, regardless of where it is. This just helps us be able to keep track of what's there, but also to be able to give a good report back to the owner after the fact, where we can actually include pictures of what we're referring to so that you can see what these systems are. Anything that we can't take pictures of, we'll be writing down. So writing down the thickness of the insulation or notes that the staff gives us about what's going on, the counts for the lighting, how many of each light fixture we see, that type of thing. After the site visit, then comes the follow-up. So as I've been mentioning, we'll be sending out a report which gives the information on our findings and recommendations of what can be done. And we'll discuss this report with the owners. I'll go into more detail on the report in the next slide, but we want to have this discussion so that we know exactly, so that the owners know exactly what we're recommending and sort of have a good sense of what these systems are. We'll also mention hazard mitigation. So if we run into any unhealthy situations in the buildings, any places where there's health hazards, whether that's CAS or mold or things like that, then we'll want to bring that up with the owner and discuss that with them. And if it's sufficiently bad, then we may want to really emphasize the owner deals with it and ask for photo documentation that it has been handled. And this may actually move into follow-up site visits where we come out and we determine that it has been taken care of. Or these site visits may be something more energy related, where if we decide that we want to do further testing on, for example, duct leakage and determine exactly how much leakage there is, and we need to come out a second time to test the ducts or do duct blasting testing or something along those lines. There's some things that are installed that won't be visible after the project is completed. And so we'll want to see those in person, like wall insulation. The walls might get filled up, and so we'll want to see if the insulation is being put in and the quality of the installation before the walls get covered up. For the report, most of, I'm sure all energy auditors will have a general format for the report, but these are the main sections that we'll be putting in. The cover page just goes through, just sort of gives the basic information of the site. And so the report will want to go into details on all of the measures that we're recommending, as well as the existing conditions, so that both the owner and any contractor that the report is sent to can really recognize what's happening and be able to follow it. So the report needs to be digestible, but also detailed enough that contractors will know exactly what we're recommending. Generally, we'll also have an appendices section where we give more information that isn't necessary in the main report, and photos. We won't include all the photos we've taken, but we'll include enough that it gives a very good sense of what systems we're talking about. So this is just a sample of a report, just a couple of pages of it. The cover page gives an outline of what this building is, what the report is about, who we're sending it to, who we are, etc. And then over here on the right-hand side, this is just a sample of a measure for exterior lighting. But we've got the existing conditions up on top, photos of what we saw, different types of light fixtures, recommended improvements where we go into details about the recommended improvements, and we also say, like, these are the individual lights that we saw that we're recommending get replaced, and these are the replacements that we're recommending, so that people sort of know where to go if they're looking for new lights. So that is the basics of what an energy audit is and what you should be going through. The key takeaways are here, but basically we start out with a talk with the owner and getting basic information about the building. We move on to the on-site audit where we look at all the systems and document them, and we go into a selection of units to see the systems in the units. And then finally, we follow up with the report and with any follow-up comments and feed and sort of back and forth with the owner to determine what needs to be done to make the building as efficient as possible. That is it. Thank you very much. We now have time for some questions. I believe Steph has been sort of fielding those for a little while, but.
Yes, thank you, Sebastian. So one of the questions is where can we find the measures incentivized for the Oregon Multifamily Energy Program? And those are available in the program handbook, which is on the website, and we will put the website up at the end of this. But the website is OregonMultifamilyEnergy.com, and you can find out information about the measures that are incentivized through that link. Additionally, we had a question come in about who can conduct an energy audit for the multifamily energy program. And this is generally conducted by a third party from the property owner themselves. So we do ask that you are engaging an energy consultant or a licensed third party to be able to conduct that energy audit and submit materials to the program. So those are the questions we have right now. I just want to encourage everybody, if you have any questions, please post them in the question box, and we're happy to answer them. I do want to also just emphasize that this recording, this webinar has been recorded, and it will be posted to the program website within a few days of the broadcast. And additionally, we would also love your feedback on this training and also additional ones that are conducted. So there will be a survey that is prompted at the end of this, so please do take that. Additionally, we have another question that just came in about will the slide deck be available as well, and yes, it will be on the website. And lastly, I just would like to thank everybody for attending today, and please join us for future trainings. The next training for the multifamily energy program will be on August 23rd. And this is where our team members will go into energy modeling best practices. So taking the information from the energy audit and translating that into an energy model. And what are some of the best practices for that process. If you'd like to sign up for any of the upcoming trainings, please feel free to visit the website, OregonMultifamilyEnergy.com, where you can find all of the trainings that are listed. And once again, we'll post all the recordings if you can't join us live. So I'd really like to thank Sebastian for joining us today. And if you have any questions, please feel free to reach out to either one of us or any of the Oregon Multifamily Energy Program energy analysts. They're happy to also answer your questions about your projects and talk more specifics. So thank you everybody for joining and have a wonderful day.